Hello and welcome to the latest how to code a game like Minecraft in Unity video. Following on from the last video of doing fast clouds, we're now going to do fancy clouds, which essentially means we're going to make them 3D as opposed to just a flat plane of clouds. Before we get into that, I just want to quickly say, when I make these videos, I do myself a little cheat sheet. I work everything out in advance and then I put together a document like, well, this is the document for this video, and as you can see, I've written it in a code editor just because it's easier to see the code when all the syntax is highlighted. And the reason I'm telling you this is I've decided I'm going to start sticking this on the Patreon page for the Patreons, because I know I've only promised to thank them in the videos and things like that, but I do want to try and give them something extra. It's a small thing, but I'm going to start putting my little cheat sheets that I create for myself to make the videos on there. So let's get straight into the video itself. So the first thing I want to just fix before we get started is if I hit play here, you'll notice, I didn't notice it in the last video, but you'll notice that when we first start off, the clouds are in the wrong place. As soon as you move out of the chunk, they move to the right place. So if we go into our cloud script, and the reason for that is that when we create our clouds, which is here, we're creating them from a 0, 0 position, and they don't get updated straight away. So what we need to do is we need to factor in the position of the center of the world, basically where the player is going to be. Seeing as we've already set the position of our cloud parent object to be in the middle of the world and essentially the spawn position, we can just do something similar here. So what we're going to do is say position plus equals transform dot position. However, if we just left it at that, we would actually have the bottom left corner of the cloud tiles, or the overall tile map at the player's position. So as you can see, the corner of the clouds is above us, and we need it to be centered. So we'll do that by adding to the transform.position a new vector3, which is going to be cloud text width divided by 2f, 0 for the height obviously, and then cloud text width divided by 2f. And when I say plus, I obviously mean minus. So that should center it. However, we're not quite done. If I press play again, you can see we have our clouds. They're centered above our heads. However, when we move, they suddenly get lower. And that's because we've changed the position here. By adding the transform position, we've added the height of this. And this is already set to the cloud height, and we don't want that. So what we can do for now, we might clean up this code later. But what we can do for now is we just say position dot y equals cloud height, just to reset that back to where it should be. So now if we press play, when we start off, our clouds should be centered and they should be at the correct height. Magic. Okay, with that done, let's get into the video itself. So the first thing we're going to do is drop to the bottom of our clouds file, and we're going to create a new enum. So public enum, and if you're not sure what this is, it's kind of just like a list of options. Like for example, in the texture settings, when you import a texture, you have the drop down menu for filter mode, the texture filter mode. You can have point, bilinear, trilinear, etc. That is essentially an enum, what an enum looks like. So it would be, the enum type would be texture mode or whatever it is, filter mode, sorry, and then your options will be point, trilinear, bilinear. So in our case, we're going to make cloud style, and our options are going to be off, fast, and fancy. And now we want to go into our world class, and we want to go down to our settings, which is right at the bottom. And in our performance, we'll stick it just below enable threading and say public cloud style clouds equals, we'll give it a default setting obviously, cloud style dot fast. But we're not done there. We want to actually apply this to our settings. So if we go back to our editor and we open up our main menu scene and we just quickly run this, go into our settings, click done and close that. If we now open our settings file, we should find there we have our extra cloud settings stored into our settings file. So now that we've got it in our settings file, we want it to be in our settings menu as well. So if we go into our canvas drop down, just turn our main menu off and open up our settings menu, and you want to create in here a drop down menu. So if we go to UI, I don't think there's a Text Mesh Pro version for this. Oh no, there is. Okay, I tell a lie. There is indeed a Text Mesh Pro one. Let's just switch this to the front view so we can see what's going on. So the drop down label, if we drag it into our heading, our settings menu, it will automatically get put into this list, and we are going to rename it first of all, clouds type. We want to set our scale to 2 because that's what we had the scale on the rest of it. If we go down to label, we can set our font settings. So we want our Minecraft font. This size I believe was 20. We want the font color to be white. And back in clouds type, we have this image here. We want to change that to our text box image. So it's starting to look a bit more like a Minecraft thing now. And we'll just quickly drag it up here as well. No, we'll go one further. We'll leave it there. And then we want to go into this template. Now this template thing is the actual, if I just turn this on so we can see it, is the actual what the drop down menu looks like. So we need to also change these. For the item label, obviously we want to set the font and we want to make the size correct, 20, and we want to set the background color, or the font color, sorry, to white. For the check mark, we'll just give it the Minecraft, there we go, we'll just set it to that. And then the background, I want to leave that none and set it to black. And then finally, I think, is it viewport? We also want to set to black. Is it template? There we go. Template, we want to set the UI source image to our Minecraft text box and also give that the color black as well. So now if we disable template and if we press play, you can see we have our options. And you can get rid of that Minecraft. In fact, I think I will get rid of it. That looks a bit silly. So if we just go back to the check mark and we'll use a tick. Tick looks fine. Yeah, that'll do. So if we go back up to our clouds type and we scroll down here, we have our options. So option A is going to be clouds off. Option B is going to be clouds fast, and option C is going to be clouds fancy. Now, for this to work the way I'm about to show you, this needs to be in the same order as the enum that we just created. So in clouds here at the bottom, we have off, fast, fancy. It has to be in the same order as that. These can be accessed as an index. So rather than off, fast, fancy, you can also access them as 0, 1, 2. So we're going to be doing that 0, 1, 2. So it needs to be the same order. It can be whatever order you want as long as they're both the same order. So with that done, let's go into our scripts and find our UI folder and our title menu. And we need a reference for that drop down menu. So let's just put this at the bottom here. Public TMP dropdown is the one we want, and we'll just call it clouds, and we'll go back in here and drag it in before we forget. Title menu, and then at the bottom here we have this, and we just drag across our cloud type drop down menu. And then go back into title menu, and in enter settings, somewhere at the bottom here, we can just say, sorry, other way around, clouds.value equals, and by casting it as an int, we then get the number. So settings.clouds. So that's setting the value of the drop down menu to the value that is being stored in our settings file. So if we first of all turn our settings menu off, because our script obviously only applies when the settings menu gets opened. So if we press play now, go into our settings menu, we can see it's set to fast. However, if we open up our settings file and we change this to 2 and then run it, you can see it's set to fancy. So now we just need to make it work the other way, because right now if we change the setting and go out and come back in, it's still on fancy because we're not saving it. So that's easy enough done. We want to go to leave settings and just do the same thing in reverse. So settings.clouds equals, and this time we're recasting it as a cloud style enum. Cloud style clouds.value. So this is basically doing exactly the reverse of what we did up here. So if we press play now, we can see our clouds are set to fancy, turn them off, and they're off. So let's just turn them off for a second, and then we can leave the menu and open up our scene for our world. Don't forget to save your scene, by the way. Let's go into our clouds file, and we want to go up to update clouds. And all we're going to say at the top of here is if world.settings.clouds is equal to cloud style.off, then return. Spelled correctly. So all this is saying is if clouds is set to off, then there's no point in doing any of this, so don't do any of this. And then if we just copy this, we also want to put it in, well, we can put it here. We should put it in all of them. Put it in load cloud data and in create clouds, so that none of these functions run if clouds are turned off. Alternatively, you could delete the component, but then it makes it a bit faffier if you ever decide to turn, like if a player decides to change the cloud settings from the menu in the game, because then you'd have to recreate the component and load the clouds again. So actually, yeah, in that note, we will load the cloud data regardless, so we'll leave that one. But you have it in create clouds and update clouds. So now, because the last thing we left our settings on was off for the clouds, we should have no clouds when we press play. Okay. Whereas if we go into our settings file and we just change this to 1, which was fast clouds, we should now have fast clouds. There we go. So that's our cloud settings working. Let's just open that up, change that to fancy clouds, and then let's make fancy clouds work. So in our clouds file, I want to go down to create cloud mesh. Here we are. And we're going to change this to create fast cloud mesh, because this is going to handle the fast clouds that we're already doing. We're going to create a new function for handling the fancy clouds. And then up in create clouds, we want to modify this so that it creates a mesh depending on what our setting is. So say mesh, cloud mesh, and then we want to say if world.settings.clouds is equal to cloud style dot fast, then cloud mesh equals create fast cloud mesh. And it's else. I know we've got 3 settings, but we don't need to do else if, because it's never going to get to here if clouds is off. Because if clouds are off, then it never gets past this point. So else cloud mesh equals create fancy cloud mesh. We don't have that function yet. Apparently we don't have this function either. Oh, I haven't given the argument, sorry. So the argument is obviously x and y, and the same argument will be applied to this. And then down here, we're just, instead of calling the function, we're going to pass in cloud mesh. So now we need to create the actual cloud mesh function. So let's go put this below create fast cloud mesh. Private mesh create fancy cloud mesh, and it's going to take in an x and a y int. So we can copy a bunch of stuff from here. In fact, we can copy the whole thing and we'll just delete what's inside the loop. So copy that whole thing, and that actually wants to be a z, not a y, and then we're just going to delete all of this. So the difference here in what we're doing in this one and what we're doing in this one is that in this one we're just creating a flat face. We always know which way that face is pointing. It's always down towards the player, and it's only one face. However, here we're going to be creating 3D faces, kind of like what we do with the chunks. So we're going to kind of copy what we do when we create a chunk. But because we're going to be changing quite a lot of it, rather than just copy it over and edit it, I'm going to rewrite it from scratch. So the first thing we do once we get into it, so obviously this is looping through all of the different points within this cloud segment. Cloud segments, I think, were 16 wide, so this is going 0 to 16 or whatever. This is getting the value within the overall cloud mesh, so it gets us a tile position. And then we're saying if there is cloud at this position, do whatever we do in here. And then in here, we're going to loop through neighbor points using face check array, much like we do in the chunk one. So for int, with inside the brackets of course, for int p equals 0, p is less than 6, p++, and then inside here we want to do a quick check and say if the current neighbor has no cloud, draw this face. So if there is cloud in the neighbor, we don't want to draw the current face that we're looking at, because then it would just be up against other cloud and you're not going to see that. So the check we're going to do here is we'll say if check cloud data, and again this is a new function that we haven't created yet, so we're going to have an error showing up until we do that creating. I'm going to say new vector3 int, because that's what we're going to pass in, xval not zval, and that's going to be plus voxel data dot face checks p, and that is also going to give an error because presently face checks is vector3, and we're going to be taking in a vector3 int, so we're going to fix that as well. But for now, let's just finish off our function. So then we add our 4 vertices for this face. We do that by saying, rather than, I'll just quickly open up the chunk thing so you can see which bit we're copying. It should be fairly obvious, but just to make it clear. So this is what we're copying right now, this whole section here. So right now we're going to do this bit, but we're going to do it slightly differently this time. So we say for int I equals naught, I is less than for I plus plus. And we're doing this because it's going to make life a little bit easier. So vector3 vert equals new vector3 int x increment 0 z increment, and then vert plus equals voxel data dot vox, spell voxel data right, voxel data dot voxel vert, and the number is voxel data dot voxel tries pi. And yeah, sorry, as I was saying, the reason we're doing this for loop rather than just typing it all out like this is because we're going to need to modify the y value of these vertices, and it's a lot easier to do that this way in a for loop than it is to do it this way where each of them is individually written out. And also it's cooler to use a for loop. For loops are cool. And then we just say vertices dot add vert, and then if we go back up here we can just grab this bit because that bit doesn't change. And then also if we go into chunks we can grab this bit because we are using the same vertices data as the chunks, so we can use the same triangle data, although we're going to have to swap this for vert count. So before we get into creating this function, let's just go fix that voxel data thing I was talking about. I think I've mentioned this before. When I first started this Minecraft series, I didn't actually know about vector3 int. I didn't actually know about a lot of things. I still consider myself to be quite a novice at coding in general and Unity and all that. But when I first started this Minecraft thing, I did not know a thing. I'm surprised I managed to get through a whole video looking back. So anyway, vector3 ints are much more practical for face checks than vector3s, and the reason for that is because we're never taking a world position and holding it up against a face check. We're always checking the other way around. We're always getting our face check and checking it against the world position, and vector3 ints can be added to vector3s. So there's no reason why this can't be a vector3, because when we need to actually add it to a real world position, we can just add it. We don't need to convert it. Whereas when we've got it as a vector3, we need to recast everything as an int when we want to use it as an index. So we're going to make this vector3 int, and then we need to make all these vector3 ints, and then we need to delete all of these. And there we're done. So now that's a vector3 int rather than a vector3, and that affects nothing because everything that we're using face checks for works fine as a vector3 int. If you look in chunk, there's no errors because we've changed it. It all works perfectly fine. But now, when we use face checks, we don't have to recast anything as an integer when we want to use it as an index or something like that, which we're going to do. So go back into our cloud, and we need to create this cloud, check cloud data, which we will just put here. And this is going to be a bool. So this is a bool that returns true or false, depending on if there is cloud at the given point. And the reason we're creating a function for this is because we need to know what to do if the cloud position is outside of the cloud texture array. I think it's 512 by 512 it was. If we pass in, because we're doing face checks where we check left, right, front, back and everything, if we pass in 512 because the array goes 0 to 511, if we pass in 512 we need to know what to do, because if we don't do anything it's going to return an error because there's nothing there, it's outside of the array. So this function is going to return a value no matter what value we pass in, whether or not it's outside the array. So let's just start off private bool check cloud data, and it's going to take in a vector3 int, which we're going to just call point. And then the first thing we're going to do is, because clouds are two-dimensional I mean, we're making them three-dimensional, but the clouds themselves is two-dimensional data. So unlike chunks where there can be 128, 256 blocks high, clouds are technically one block high. So we never need to check above or below them. So because clouds are 2D, if y is above or below 0, return false. So remember, this is returning false if there is no cloud data there. So what that means is if the check is above or below it, it's going to return false, and then our function up here is going to draw the face for that cloud. And the check is simply if point.y does not equal naught, return false. So the only acceptable number for y is naught. If it's above naught, then we return false, and if it's below naught, we return false. So after that, we're going to just cache our x and our z values. Point.x int z equals point.z. And then we're going to say if the x or z value is outside of the cloud data range, wrap it around. So what that means is, what we're going to do is, if it is, for example, so the cloud data goes from 0 to 511, if it's 512, we're going to return 0. So we're going from one side of the map, the cloud map, to the other side. So it wraps it around infinitely. So if .x is less than 0, x equals cloud text width minus 1. So it's saying if it's less than 0, then it's going to equal the max. If it's minus 1, it's going to equal 511. So when we hit the edge of the map, we're checking the face off the edge of the cloud map, we're returning the cloud data at the other end. If point.x is greater than cloud text width minus 1, x equals naught. And then we just do the same for the z value. And then we return, because our cloud data is a bool, we just return our cloud data value for x and z. So that should have got rid of this error up here. There we go. And it's taking in, because voxel data face checks is now a vector3 int, it's taking in that vector3 int fine. If we'd left it as a vector3, we'd be getting a type error here, because this is set to take in a vector3. And if it was taking in a vector3 int, sorry, and if it was taking in a vector3, we'd have to recast point x and point z here as integers before we could use them. And I've just realized we shouldn't have copied this from up here. We should have copied it from here. So let's just fix that. That would have made for an interesting looking set of clouds. And also, while we're fixing things that I've missed, we actually have to increment our vert count. So if we go back into Unity, we should find our errors have gone. Good. And we'll just do a quick test run. And we have 3D clouds. So, as you can see, we're not quite done yet. If I zoom into one of these clouds, we have a slight problem, and that's that our opacity is doubling up. So when a cloud overlaps, it doubles up the transparency. And obviously that's not how the Minecraft clouds work. Now we're going to fix that, but before we fix that, there is also the issue that clouds in Minecraft are, well, I read they were 4 blocks high, but I've had differing opinions from people I've spoken to about it. Either way, I'm just going to put a value in, and you can set your clouds to whatever height you want. So go to the top of our cloud data, or our clouds file, and we're going to create a new variable. Actually, we'll put it up here and make it public. Public int cloud depth. I'm going to set it to 4. Like I said, I read somewhere that clouds were 4 high. And then the thing that I was talking about in here, is it here? Yeah, in here, that we will be making easier by doing this in a for loop rather than the way we did it before, is that now we can say vert.y times equals cloud depth. So if we just quickly look in our voxel data, you can see that we're always, sorry, not face checks, in our verts here, everything's 1 or 0. So we don't need to worry about 2s or 3s because we're working in units of 1. If you're trying to be clever and you've made your Minecraft game work with 0.5 or units of 3, then you're going to have some things to work out to make this work. But because we're using 1s and 0s, then what this means is that if we times it by cloud depth, we either get 0 because 0 times anything equals 0, or we get the cloud depth because 1 times anything equals what the anything is. So what this means is that all the vertices that are at 0 will stay at 0, and all the ones that are at 1 will now be at whatever cloud depth is. And that should be all we need to do to make the clouds taller. There we go, we now have deep clouds. So let's fix this transparency problem. Now, again, with shaders, I am not the best person to ask on how things work. However, I've once again managed to glean enough information to make this work. So, what we're going to do is we're going to use a stencil. So, first off, inside of our pass, we're going to create a stencil code block. And we're going to say ref1. And then after that, we're typing comp greater. And then finally, pass inc sat. So what happens in this block is that it checks the pixel that it's currently drawing. Basically, we're flagging each pixel that we've drawn on in this shader. So if it encounters a pixel and that pixel is already flagged, it will not draw another pixel on it. That's what that code block does. What these individual lines actually mean, I'm not 100% certain. Shaders is not my strong suit. So now, if we go back to here and press play, you can see we now have our clouds, but they're not drawing over each other, and they are 4 blocks deep. And you can make them however deep you want. And if we drag our player across the world a bit, you can see they move with us because all the other code that we created in the Fast Clouds video still works the same way it did before. We're just now using a 3D mesh. So that's the end of this video. All that's left to do now is to thank my amazing Patreons. There's been a couple more since the last video. I greatly appreciate that. As always, special thanks to Professor DJ for being one of the top Patreons, and he has been joined in the Sugar Daddy / Mama level by Dave Maldine. Sorry if I've butchered your name. So extra special thanks to you guys. Thank you to the rest of our Patreons. Thank you to everybody who watches, everyone who likes, subscribes, all the YouTube stuff, rings the bell, whatever. Discord channel people, you're all greatly, greatly appreciated. And I will see you next week for another video. Bye-bye.